In the first part, we have calculated the vector equation of lines when there were two possibilities. Either the fixed point and the directed vector is given, or the second one is when the two fixed points are given. Now you will find out the nature of the lines. For this part, we know that say R is equal to, this is line L1, 1, 2, minus 1 plus S times of 2, 3, 2. This is the line S L1. With this is as the fixed point, and this is the directed vector of that line. And there is line L2, which is R there. That is equal to minus 1, and 1 plus t times of 1, 2, minus 1. These are the two lines with the two equations where this thing is known as to be called B1 and this thing is known as to be called B2. These are the two directed vectors of these two lines. We will first check that if B1 is equal to t times of B2, then the lines are parallel to each other. Here B1 is equal to 2, 3, 2 t times of 1, 2, minus 1, and we see that from this equation 2, 3, 2 is equal to t, 2t and minus t. So if we equate these two, the first one t is equal to 2. If we equate the second one, 2t is equal to 3. This implies that t is equal to 3 by 2. And the third is t is equal to minus 2. So you have seen it here that all three t's are different. Even one is different, even then they will not be parallel. But here all are different. So the line L1 is not parallel to L2. So this is the first part of that calculation there. Then, if they are not parallel, so we draw this chart as this, that if A is equal to t times of B, then the lines are parallel. And if A is not equal to t times of B, then they are non-parallel. And when they are non-parallel, then there are two things in it. One thing is known as to be called intersecting, and the other thing is known as to be called skew. If we have to draw the shape of this is the line L1 is parallel to L2. And for this part, this is line L1 and this is line L2. Then they are intersecting each other at this point P there. And for the skew lines, this is line L1 and this one is line L2. So you have seen it here, they are neither parallel nor they are intersecting. So that is why they are said to be called skew lines. But how will you differentiate these two lines? For this example, let's say we take this first example where L1 and L2 are given there. Then for the line L1, the x coordinate of this in the parametric form is 1 plus 2s. Y equal to 2 plus 3s and z is equal to minus 1 plus 2s. For this line L2, x coordinate is equal to -1 plus t, y equal to -1 plus 2t, and z1 is equal to 1 minus t. So these are the parametric forms of these two lines, L1 and L2 there. Now you will equate out of these three two. Let's say we equate x and x and we equate y and y. If we equate x and x, then 1 plus 2s is equal to -1 plus t, or t minus 2s is equal to 2. Let's say that is equation number 1. If we equate y for these two, then 2 plus 3s is equal to -1 plus 2t. This will become 2t minus 3s is equal to 3. Let's say that is equation number 2. Now we will equate, solve 1 and 2 there. 1 is there, t minus 2s is equal to 2. So you multiply this equation by 2 there. So 2t minus 4s is equal to 4, and the upper equation is already 2t minus 3s is equal to 3, and we solve them simultaneously. It is positive, it will become negative, it is negative, it will become positive, this is positive, it will become negative. This and this they are going to cancel out. Minus 4s plus 3s is equal to minus s, and that thing is equal to 4 minus 3 is equal to 1, or s is equal to -1. Now we put any value into either equation 1 or 2, then e minus 2s is equal to 2, t minus 2, s is -1 is equal to 2, or t plus 2 is equal to 2. So t is equal to 0. Now we check in the third quadrant of Z there, for this and for this. So Z coordinate for this part is -1 plus 2s, and s value is -1. So this value of z is equal to -1 minus 2, and that thing is equal to -3. Then for L2, z coordinate is equal to 1 minus t, and that is equal to 1 minus 0, or that is equal to 1. So z is equal to 1. You have seen in this part that z is not same. Both z's are different from each other. So the lines are thought to be skew lines. And if z coordinate is same, then this x, y, z, either you put s or t, will have the same coordinates there, and that will give us the point of intersection between these two lines there. Now, this second part of this, there is angle between these two lines. We know one thing, that B1 is equal to 232, and B2 there is 1, 2, -1. So if we use the dot product between these two vectors lines, B1 dot B2 is equal to B1 magnitude, B2 magnitude into cos of angle between these two. Then cos of theta is equal to B1 dot B2 over B1 magnitude into B2 magnitude. Theta is equal to cos inverse of B1 dot B2 over B1 magnitude, B2 magnitude. So this is the angle between the two vectors lying there. So if B1 dot B2 is equal to 0, then the line L1 is perpendicular to line L2. If B1 dot B2 is less than 0, then angle between these two lines will be acute angles. And if B1 dot B2 is greater than 0, then angle between these two lines will be obtuse. So here we will check the angle between these two lines. So B1 dot B2 is equal to 2 into 1 plus 3 into 2 plus 2 into minus 1 . So this thing is equal to 2 plus 6 minus 2. That thing is equal to 6, which is greater than 0. So angle between these two lines will be obtuse angle between the lines. And we can calculate it like this, that theta is equal to cos inverse of B1 dot B2 over B1 magnitude, B2 magnitude. So that thing is equal to cos inverse of B1 dot B2, we have calculated it equal to 6 over B1 magnitude. If B vector is equal to xi plus yj plus zk, then B magnitude is equal to x square plus y square plus z square and whole square. So the first value will be equal to 4 plus 9 plus 4 square root multiplied by this magnitude 1 plus 4 plus 1 magnitude. So this is equal to cos inverse of 6 over and that thing is equal to 0.934 in terms of radians there. And if you have to calculate in terms of the degrees, it is less than 0, greater than 0, then it will be acute, and less than 0, it will be obtuse. So it is equal to, if it is degrees, 53.5. So this is the angle in terms of the degrees of the two lines. So if B1 dot B2 is greater than 0, then it is acute angle between the two lines. And if B1 dot B2 is less than 0, then it is the acute angle between these two lines. So this is the way that we can change and convert the lines in the three different forms. Then the angles between these two lines and the three different forms of the angles of these two lines. And we will explain the next topic of the distance from a vector equation of line in the third video of this